Every AI tool you use, Claude, ChatGPT, Cursor, VS Code Copilot, they're all trapped. They can think, reason, and generate code, but they can't actually do anything in the real world. They can't read your database, check your GitHub issues, or query your company's internal APIs. At least not without custom integrations built from scratch for every single combination of model and tool. That's where the Model Context Protocol comes in. MCP is an open standard. Think of it as USB-C for AI. One universal connector that lets any AI model plug into any tool, database, or service through a single standardized interface. No more building custom integrations for every combination. In this video, I'll explain exactly how MCP works, what the architecture looks like, and I'll walk you through setting up your own MCP servers from scratch. Let's start with the problem MCP solves. Imagine you're using Claude, and you wanted to query your PostgreSQL database, read files from your GitHub repo, and search your company's Confluence docs. Before MCP, you had two options. Option 1. Copy-paste context manually into the chat, slow, error-prone, and limited by context windows. Option 2. Build custom API integrations for each tool, for each AI model. If you have 5 AI tools and 10 external services, that's 50 custom integrations to build and maintain. This is the N times M problem. N models times M tools equals an explosion of custom code. MCP eliminates this entirely. Build one MCP server for your PostgreSQL database, and it works with Claude, ChatGPT, Cursor, Windsurf, VS Code, and every other MCP-compatible client. One server, every client. That's the power of a standard protocol. Now let's break down the MCP architecture. There are 3 key roles. First, the MCP host. This is your AI application. Claude Desktop, Cursor, VS Code with Copilot. These are hosts. The host is what the user interacts with. Second, the MCP client. This is a component inside the host that manages the connection to a specific MCP server. Each host creates one client per server it connects to. Third, the MCP server. This is a lightweight program that exposes capabilities to AI clients. It's the bridge between the AI and your external tools. The communication flow works like this. The user talks to the host. The host's MCP client discovers what tools the server offers. When the AI needs to use a tool, it sends a json-rpc 2.0 request to the server. The server executes the action and returns the result. The AI incorporates the result into its response. It's a clean, request-response loop over a standardized protocol. MCP servers expose 3 types of primitives. Let me explain each one. First, tools. These are functions the AI model can call. Think of them as actions. Query a database, create a GitHub issue, send a Slack message, search documents. The server declares what tools are available, what parameters they accept, and what they return. The AI decides when to call them based on the user's request. Second, resources. These are data sources the AI can read. Unlike tools which perform actions, resources provide context, a file's contents, a database schema, a configuration file, a web page. Resources help the AI understand your environment without needing to execute anything. Third, prompts. These are reusable templates that guide the AI's behavior for specific tasks. A code review prompt, a SQL query generator prompt, a documentation writer prompt. They encode expert workflows into shareable templates. Tools, resources, and prompts. Actions, data, and templates. That's the complete primitive set. Now let's talk about transport. How does the client actually communicate with the server? MCP supports 2 transport mechanisms. The first is stdio, standard input and output. The client spawns the server as a subprocess and communicates through stin and stout. This is the most common approach for local MCP servers. It's simple, requires no network configuration, and is how most desktop tools like Claude Desktop connect to servers. The second is streamable HTTP. This uses HTTP with server-send events for streaming responses. It's designed for remote servers running on a different machine or in the cloud. This is how you deploy an MCP server for a team or expose it over the internet. Most local setups use stdio. Production and team setups use HTTP. Both carry the same json-rpc 2.0 messages underneath. Let me walk you through setting up your first MCP server. I'll show you a Python example because Python's MCP SDK is the most mature. First, install the MCP package. Run pip install MCP. Now create a file called server.py. Import fastMCP from the MCP server.fastinc module. Create an instance, MCP equals fastMCP with the name myServer. Now let's add a tool. Decorate a function with an MCP.tool. Let's create a simple one. A function called get_weather that takes a city parameter and returns weather data. Under the hood, it could call a weather API, query a database, or return mock data. The decorator registers this function as a tool that any MCP client can discover and call. To run the server, add the standard if __name __equals _main block and call mcp.run. That's it. You now have a working MCP server with one tool. Run it with Python server.py and any MCP-compatible client can connect to it. Now let's connect this server to Claude Desktop, the most popular MCP host. Open your Claude Desktop configuration file. On Mac OS, it's at /library application support, claude/claude_thup_config.json. On Windows, it's in appdata/roaming claude/. The configuration is simple JSON. Under the MCP Servers key, add an entry for your server. Give it a name, specify the command to run it, Python, and the arguments, the path to your server.py file. Save the file, restart Claude Desktop, and your tool appears automatically. Claude can now see your get_weather tool, and when you ask, "What's the weather in London?" Claude will call your MCP server, get the result, and present it naturally in the conversation. No copy-pasting, no manual API calls. It just works. Let's look at some real-world MCP servers that are already available. The MCP ecosystem has exploded. There are over 6,000 registered servers as of mid-2026. The official Anthropic servers include a file system server that lets the AI read and write local files, a GitHub server for repositories and issues and pull requests, a PostgreSQL server for direct database queries, a Slack server for messages and channels, a Google Drive server for documents and spreadsheets. The community has built servers for everything: Jira, Notion, Linear, MongoDB, Redis, Elasticsearch, AWS services, Docker, Kubernetes, you name it. You can browse the official registry at the MCP Servers directory. Most are installable with a single command using UVX or NPX. Let me show you a more practical example, setting up the official PostgreSQL MCP server. This lets any AI assistant query your database directly. The configuration is straightforward. In your MCP client's config file, add the PostgreSQL server entry. The command is npx. The argument is at modal context protocol/server postgres, and you pass your database connection string as an environment variable. Once connected, the AI can see your database schema as a resource, and it has tools to run read-only SQL queries. Ask Claude, "What are our top 10 customers by revenue?" and it will write the SQL, execute it against your actual database, and present the results, all through MCP. No more copying schemas into prompts. No more manually running queries and pasting results. The AI has direct access. For developers who want to build production-grade MCP servers, here are the best practices. First, keep servers focused. One server per domain. Don't cram database access, file operations, and API calls into a single server. Second, implement proper error handling. Return clear error messages that help the AI understand what went wrong and try alternatives. Third, add authentication. For remote servers, use OAuth 2.0 or API keys to control access. MCP's HTTP transport supports standard auth headers. Fourth, limit scope. Use read-only database connections, restrict file access to specific directories, rate limit API calls. The AI has agency, so guard against unintended actions. Fifth, document your tools clearly. The tool descriptions and parameter schemas are what the AI reads to decide when and how to call them. Good descriptions lead to better AI behavior. Let's zoom out and talk about where MCP fits in the broader AI landscape. MCP is not the only approach to giving AI tools. OpenAI has function calling. Google has tool use. LangChain has its own tool abstraction. But MCP is different because it's a protocol, not a framework. It's open source, model agnostic, and designed for interoperability. Any model can be an MCP client. Any service can be an MCP server. This is why adoption has been so fast. OpenAI added MCP support to their Agent SDK. Google is integrating it. Microsoft adopted it for VS Code. The industry is converging on MCP as the standard. If you build an MCP server today, it works with every AI tool tomorrow. To summarize, MCP is the universal connector between AI models and external tools. It solves the N times M integration problem with a standardized protocol. The architecture is simple: hosts, clients, and servers communicating via json-rpc over stdio or HTTP. Servers expose three primitives: tools for actions, resources for data, and prompts for templates. Setting up a server takes minutes with Python or TypeScript. The ecosystem already has thousands of pre-built servers for popular tools. And because it's an open standard, your investment in MCP servers pays off across every AI tool you use, now and in the future. If you're building AI-powered applications, or if you just want your AI assistant to actually interact with your tools, MCP is the protocol you need to know. Start with the official servers, build your own for custom use cases, and join the ecosystem that's defining how AI connects to the real world.